Good evening. Let's discuss today's maths paper as far as Jee Maths 2015 is concerned. It was a collection of 30 single choice problems. I am going to discuss set B of that paper. In the first question, and you have to find out in the first question and you have to find out sum of coefficients of integral power of x in the expansion of this, where you can observe starting from the first term, every alternate term is going to be the required expression whose coefficients actually we are bothered about. And if I consider that expression to be equal to this, which you can clearly check, we can write it as the combination of two different binomial expansions. Like this, which is simplifying to this, and which was matching with the option 4 given in that problem. Fine. In the second problem, you had one polynomial function of 4 degree with extreme values being taken at two different abscissas 1 and 2, and then on the basis of it we have one limit given as equal to 3, but you can check, we can write down that limit as equivalent to this after cancelling off 1 from both the sides. And since fx is a polynomial of 4 degree and we have denominator as x squared, clearly then that implies f of x should have 3 terms only, as the 4 degree term, 3 degree term and 2nd degree term. But since this limit is 2, clearly then the coefficient of x square in that function should be 2, and you can't have any x or constant term in that expression, otherwise you won't get 0 by 0 form here, and result is never going to match with 2 then. And as far as a, b are concerned, for that case we had two information that at x equal to 1 and 2 we have extreme values. Clearly then its derivative must have 1 and 2 as roots. You can check 0 is already a root of its derivative. If I discard that particular value, this is the quadratic which is going to have 1 and 2 clearly as roots, implies then the sum of the root should be negative 3 by 4a, and product of the root, that is 4 by 4a, must match with equal to 2. Clearly then you can check the value of a becomes half, and utilizing that fact the value of b is going to be equal to minus 2. So that's how you can manage the value of f of x. Once you know f of x, you are interested in f of 2. You can clearly check after substituting these values there that 2 is a root of that polynomial. Hence, the answer is option 2. Fine. In the third problem, we have some information related with some data. We had 16 observations and its arithmetic mean is given to you as 16. Clearly then sum of all those observations is going to be 16 square, out of which it is given to you that if you remove one data which is 16 and then if you add 3, 4, 5 in that setup, and then you have to figure out it is its mean. Clearly then you can check you have overall 18 items. This expression is simplifying to 14, which is matching with the option 3. Fine. In the next problem, you have one series whose sum of first term you have to figure out. If you look at the general term of that expression, numerator is clearly going to be r square into r plus 1 whole square by 4, since it's a sum of consecutive cubes, and in the denominator it's the sum of consecutive odd numbers starting with 1. So clearly then the sum is going to be r square. So general term is then simplifying to this much. Since you are bothered about sum of first 9 terms, clearly you can then check that that required sum is going to be like this. See, I am subtracting 1 here just because I am not going to get any 1 square in this series, as r is going to start from 1. I am counting that 1 and I am subtracting that 1 so that I can utilize the formula. This expression you can check, it is going to simplify to the option 1. The net value is 96. Okay, in the fifth problem, one particular point, since parabola was x square equal to 8y, you can check, you can consider a variable point on this as 4t 2t square, which is clearly going to satisfy that parabolic curve. And then we have to consider, this is the point Q you have to consider in that setup, and then you have to consider a point P which divide the join of O and Q, where O is origin, in 1:3 ratio. If I consider the point P as HK, clearly you can check then line joining O and Q, we have that ratio as 1:3. So if I consider the value of H here, rather 4H, it is going to be equivalent to 4T, and as far as 4K is concerned, 4K should be equal to 2T square. Eliminating T from these two equations, you can then check this Y, rather 2Y becomes x square, which is matching with the option 3. That is what is the required locus. Fine. In the next problem, we have one quadratic equation given whose roots are alpha and beta, on the basis of which we have one general term as alpha n minus beta n, on the basis of which you have to simplify a10 minus twice of a8 by something. Let us simplify this matter first of all. If you look at a10 based on the definition, it's going to be this minus beta 10. If I collect the two terms which are depending on alpha and take alpha for 8 common, you are then going to have alpha square minus 2 inside. In a similar way, you are going to have this also. But since alpha is a root of that given quadratic, you can clearly check this bracketed quantity becomes 6 alpha. So you have 6 times alpha 9 minus beta 9, which is nothing else but 6a9, and you had twice of a9 in the denominator. Clearly that ratio is going to simplify to 3, which is matching with the option 2. Okay, in the seventh problem, you have 12 identical balls which are to be placed in 3 identical boxes, and you have to find out probability of one event that one box contains exactly 3 balls. Since we have identical balls and identical boxes, if you check in probability, even though your setup is related with identical things, you can treat them different, and later on you can take care of that assumption that those objects are actually not different. For that case, if those objects were different, you can check each and every object has got 3 choices because you have 3 different boxes. By that logic, then your answer is going to be 3 to the power 12 as the sample space. But as far as favorable case is concerned, out of those 12 objects, you need to select 3 objects for one box, and then for remaining 9 objects, we have throughout 2 choices. So this is what is going to be the required probability. Simplifying that expression, you can check it is going to match with the option 4. we have one complex number z1 minus twice of z2 by some expression as a unimodular complex number. Clearly then you can write down this expression that their moduli should be same, then only then that should be unimodular. And generally when we come across two moduli equal in complex number, what we do, we square up both the side and we try to express each side as product of complex number into its bar. After simplifying this setup, you can check the whole lot of terms which are going to cancel off. And you are going to left with mod z1 square plus 4 mod of z2 square, and similarly on the right side you are going to have this expression. Based on these four quantities, clearly you can check this, that mod of z1 square this product is going to be equal to 0, but it is given to you in the problem that z2 is not unimodular, implies this bracketed quantity cannot be 0. Obviously then that implies that mod of z1 is equal to 2, implies then the complex number z1 lies on a circle with radius 2, which is matching with the option 2. Okay, next one is related to the indefinite integral, is based on one of the standard form of integral. In such a case, you should have taken this x to the power 4 outside the bracket. Once you do that, you will find that x cube is actually going out, so you will have x to the power 5 inside, and this expression becomes this much. This x to the power 5 is clearly going to give you this hint that you need to take this quantity as t. In order to rationalize that power, let me take that quantity as t to the power 4 further. Differentiating which, you can check this integral is going to be equivalent to negative of t cube dt, and denominator is also going to be t cube. So certainly your answer is then going to be minus of t plus c, which is equivalent to and which is matching with the option 3 of that problem. Okay, next one is related to the indefinite integral, is based on one of the standard form of integral. In such a case, you should have taken this x to the power 4 outside the bracket. Once you do that, you will find that x cube is actually going out, so you will have x to the power 5 inside, and this expression becomes this much. This x to the power 5 is clearly going to give you this hint that you need to take this quantity as t. In order to rationalize that power, let me take that quantity as t to the power 4 further. Differentiating which, you can check this integral is going to be equivalent to negative of t cube dt, and denominator is also going to be t cube. So certainly your answer is then going to be minus of t plus c, which is equivalent to and which is matching with the option 3 of that problem. Okay, next one is related to the indefinite integral, is based on one of the standard form of integral. In such a case, you should have taken this x to the power 4 outside the bracket. Once you do that, you will find that x cube is actually going out, so you will have x to the power 5 inside, and this expression becomes this much. This x to the power 5 is clearly going to give you this hint that you need to take this quantity as t. In order to rationalize that power, let me take that quantity as t to the power 4 further. Differentiating which, you can check this integral is going to be equivalent to negative of t cube dt, and denominator is also going to be t cube. So certainly your answer is then going to be minus of t plus c, which is equivalent to and which is matching with the option 3 of that problem. Fine, in the next problem, it is given to you that you have to write down a plane which contain line of intersection of two given plane and that is parallel to some third plane. Clearly, when you are dealing with such a problem, family of plane would be the best way in which you can deal with it. If I consider the family of plane using the help of first two, you can check coefficient of x is going to be 2 plus lambda. That should be in proportion with 1 because they should be parallel. Coefficient of y is minus 5 plus lambda. That should be in proportion with 3. Coefficient of z is 1 plus 4 lambda. That should be in proportion with 6. After solving this equation, you can say this that you have only one unknown, but why we have one extra equation. And that extra equation is to check that assumption, whether that assumption what we have taken is possible or not. You should be getting same value of lambda from this because it's given in the problem. If you simplify this whole matter, you will find that lambda is going to be negative 11 by 2. Substituting that value in that family of plane as P1 plus lambda P2, you will find that this equation is going to simplify to which is matching with the option 2 in that problem. Fine, in the next problem we have two inequalities given, and using those inequalities you have to chalk out the region and then you have to find out the area enclosed by that. Clearly you can check first curve is related to the parabolic curve y square less than equal to 2x. Obviously less than equal to, when we have to consider the region lying inside the parabola. And then we have a straight line which is related with y equal to 4x minus 1. Origin you can check is satisfying that inequality. So clearly this is what is the region we are interested in. When we solve that pair of equation, that is y square equal to 2x and y equal to 4x minus 1, clearly you should end up getting two different point of intersections. Their coordinate after solving this pair, after substituting y here, you can y is going to be equivalent to minus half or 1. Since we have this area related to the line and a parabolic curve which is not a function directly, so it's better if you go in for this area in terms of horizontal rectangular strip. If I consider this integral where the rightmost function is y plus 1 by 4 minus the leftmost function, that is this parabola, which is y square by 2. If you simplify this matter, that is going to give you the final answer, which is matching with 9 by 32 square roots, having the third option. Okay, in the next problem, we have a particular number L as the arithmetic mean of two numbers. Clearly then L plus N, you can write it as double of that number. Further, between L and N, you have to introduce three different geometric means. When you insert three different geometric means, you can check this, that the value of all those means are going to be like this. This is how the value of GK you can manage. One thing you can check here, that the position of N is going to be 5, since between L and N you are introducing three different GMs. L is clearly going to be the first term into the common ratio to the power 4. Hence the value of that common ratio turns out to be N by L to the power 1 by 4. And utilizing which you can check GK, whose position is going to be K plus 1th term in that GP, turns out to be this much. Since it is given that you have to simplify G14 plus twice of G24 plus G34. You can check then all these powers of 4s of GKs is going to make that expression then the value of G34 would be out of which you can check if I take Ln common, I should be getting L square plus 2Ln plus n square, which is equivalent to Ln, and then this is the whole square of 2m, which is going to make it 4 ln m square, which is matching with the option 1 of that problem. Fine, in the next problem we have a family of line given and you have to find out locus of image of a particular point. Since we have infinitely many lines, obviously you are going to have infinitely many images, and then you have to manage locus of all those images. If you solve that pair of straight lines which are given, clearly you will find that 1, 2 is going to be the point of concurrency of all those family of lines. So if I consider a whole lot of lines which are passing through say 1, 2 and say 2, 3 whose image actually we are interested in lies here. If I take image of that point in this line, say that image lies at this place. If I join that pair of points, that is the object and image, clearly you can check this line in which we have taken the image is perpendicular bisector of it, and that perpendicular bisector in all the cases passes through a fixed point. If you recall, this is a special property of circle where all the chords are perpendicularly bisected by a set of concurrent lines where the point of concurrency is the center. Implies that locus is going to be a circle, and for that circle this point of concurrency 1, 2 is what is the radius, what is the center. Clearly then you can manage radius as this particular distance, as that circle has to pass through 2, 3. Hence that radius is going to be equivalent to root 2, which is matching with the option 2 of that problem. Next problem is related to ellipse. You're dealing with area of a quadrilateral, rather area of, you can say, a parallelogram, and that area is a fixed expression for any ellipse. That expression is twice of semi-major axis length square by its eccentricity. Clearly in this case you can check that a square value is 9 and the eccentricity value using the help of b square as 5, you can check that value turns out to be 2 by 3, which is going to make that area equal to 27, which is matching with the option 3 in that problem. Fine, next problem is related with combinatorics. There you have to find out all the numbers greater than 6000 using the digits 3, 5, 6, 7, 8. Mind it, you don't have any 0, so we can easily handle such a situation. Number which has to exceed 6000, that can be a 4-digit number, can be a 5-digit number. Since we have 5 digits available and repetition is not allowed. In case of 4-digit number, you can clearly check we have only 3 options to fill this place, and after that your choices are going to be 4, 3, 2. Clearly then this is going to match with 72. There are total 72 such 4-digit numbers, and in this case it would be simply 5 factorial, which is 120. Adding these two expressions, you can check your answer is going to be 192, which is matching with the option 1 of that problem. In the next problem, based on sets, we have 2 sets comprising of 4 and 2 different elements. Obviously then in case of A cross B, we are going to have overall 8 elements. And total number of subsets, if you consider, that is clearly going to be 2 to the power 8. But the condition given here is that we should have at least 3 elements involved. Obviously then we have to eliminate the empty set. We have to eliminate those cases where we have single element subset, those cases where we have 2 element subset. This value you can check is simplifying to 290, which is matching with the option 4 of that problem. Okay, next problem was related with inverse trigo. You have tan inverse of y equivalent to tan inverse of x plus some expression. Since x is a fraction, is ranging in -1 by root 3 to +1 by root 3, clearly you can check that second expression I can write it as 2 tan inverse of x also. Clearly then this expression becomes twice of 3 tan inverse x, which is simplifying to which is matching with the option 4. By the way, in this problem, even if you make a random guess, you don't have any other option other than option 4, which you can randomly guess it without looking at restriction mod x less than 1 by root 3, because you can't have any other option possible. Next problem is related with definite integral. There if you apply this property that 0 to a fx dx is equivalent to 0 to a f of a minus x dx, you can easily handle that step. Even if you apply that property, you can check that I is going to be equivalent to 2 to 4, and we have to consider, it's better if you consider b to a and here a plus b minus x property, because you don't have 0 to 4, you have 2 to 4. In that case you should have ln of 6 minus x square. Denominator you can check, the terms are going to get interchanged. The first term becomes ln of 6 minus x whole square, which is what is the second term, and the second becomes the first one, that is ln of x square. Clearly then 2i is going to be equal to 2, hence the value of I is going to be equal to 1. You will end up getting 2 because I am adding up this integral and the integral given to you, since they have common denominator, which is matching with the option 2 in that problem. Okay, next problem is related with tautology. There you can check, you have to simplify negation of this particular statement which I have written in bracket. Suppose if I take this negation inside, obviously that is going to nullify this negation. This is going to change the sign of it. If I take that negation inside, that is further going to change its sign, and then you are going to have an expression like this. After this, if I consider this expression, this sign with R, the statement R, you will end up getting this expression. And then you have you can check, this is like you are looking at a statement and negation of that statement. This is clearly a fallacy. Since that is a fallacy, and then if I am considering this expression along with fallacy, clearly the nature of this is going to dominate there, which is matching with this one, and that is straight away matching with the option 3 of that problem. Okay, and the next problem was related with height and distance. We have 3 collinear points with different angle of elevations, and there you have to find out AB is to BC ratio. You can check, this angle is 60, this one is 45, this one is 30, and we are interested in AB is to BC value. Suppose if I were to consider that as x, this length as y, this length as z, and this height as h. clearly h by z is going to be equal to root 3. H by z plus y is going to be equal to 1, and then h by x plus y plus z is going to be equal to 1 by root 3. Using which you have to simply figure out x by y value here. You can eliminate z out of it. Once you eliminate it, you will find that that is going to match with root 3, and which is matching with the option 4 of that problem. Okay, and next problem is related with limit. There if you observe, because of this expression we have to have x squared here. To take care of that extra x, I am taking that x here. This value clearly becomes 4. This is related to one standard limit that you can write it as k square by 2 where k is 2, and this quantity is approaching towards 4. Obviously then this limit turns out to be 2, which is matching with the option 2 in that problem. In the next problem, we have one VTP equivalent to some expression in terms of vector A. If you simplify that VTP, you can check you are going to have C dot A times B minus C dot B times A. But that value is given to you only in terms of 1 by 3, some scalar quantity and the vector A. Since it is given in the problem that A, B, C are all non-collinear taken in pairs, and this expression we have got it in terms of vector A, obviously then you can compare the coefficients since A and B are non-collinear. Clearly, by which then you can manage this, that C dot A has to be 0 and B dot C has to be clearly equivalent to 1 by 3 mod B mod C. Obviously then this implies that cos of the angle between B and C vector is going to be minus 1/3. Hence the value of sine is going to be 2 root 2 by 3, which is matching with the option 4. Here you have to make a note of one thing, that I am not taking negative square root of 2 root 2 here, because in case of dot product of two vectors, sine cannot be negative under any situation. That's why positive square root, which is matching with the option 4. Okay, next problem is related to matrix. You have one matrix given as this. And further it is being told that A into A transpose is given to you as 9 times a unit matrix. Clearly then this product has to match with this particular matrix. And then we have to find out the values of A and B. In order to manage the values of A and B, it's better if you compare this particular element, because that is going to automatically involve A, B and 1, 2, 2. If I consider that particular case, you can check that is going to give you this particular equation, which is going to match with 0. Then let's go in for this one, where you can check you have 2A then plus 2 minus 2B equivalent to 0, using which you can figure out the values of A and B, and you will find that the value of A is minus 2, B is minus 1, which is matching with the option 3 of that problem. In the next problem, you have something related with differentiability. It is given to you that some function is differentiable. Obviously then that implies function has to be continuous. Obviously at x equal to 3. For continuity at 3, you can check LHL value is 2k, and that has to match with 3m plus 2. And if I were to consider differentiability of that function is same as derivatives continuity, we will end up getting this kind of equation at 3. Solving this pair of equation, you can check the value of k is going to be 8 by 5 and the value of m is going to be 2 by 5. We are interested in k plus m, which you can check that is matching with 2, and that is matching with the option 4. Okay, in the next problem, it was related with Kramer's rule, and you have one system of equation given, linear equation, and you have to figure out suitable values of lambda for which that equation has non-trivial solution. And By Kramer's rule, I believe all you people are aware of this, that you have to make sure that the coefficient determinant should be equal to 0. If you figure out the value of that determinant, that 3 by 3 determinant, you will end up getting a cubic polynomial in lambda, which is and on the basis of this cubic, just you have to point out how many real values of lambda exist. Clearly you can check that lambda equal to 1 is a root of that cubic. If you factorize, you are going to get another quadratic which has again lambda equal to 1 as a root, and clearly the third root is -3. But since we have to find out distinct values of lambda, clearly that is 2, which is matching with the option 2 of that problem. In the next problem, we have one second degree homogeneous equation where you have to look for the equation of normal. And if you differentiate that relation, after collecting all the term depending on dy by dx, we will end up getting this expression. And since you have to find out normal at 1, 1, you can check this value of dy by dx turns out to be 1. Obviously then the equation of normal at such a point is going to be x plus y equal to 2 with slope -1 through 1, 1. This is a line, and if you consider the second degree equation, homogeneous equation, which was given to you, that is simplifying to a pair of straight line like this. Obviously this normal and this line are going to meet in 1, 1. This line and this line are going to meet somewhere in 4th quadrant. No need to figure out the coordinate of it, just we are looking at the quadrant in which they intersect. They intersect in 4th quadrant, which is matching with the option 3 of that problem. In the next problem, 2 circles are given and you have to find out number of common tangents. If you look at the first circle, the center of that circle is 2, 3, and its radius, that is r1 say, is 5. And for the second circle, its center is -3, -9, and its radius is 8. In order to manage the number of common tangents, we look for center, the distance between their centers, and we try to connect with r1 plus r2 or r1 minus r2. In this case, if you look at this distance, that is going to be equivalent to 13, which is r1 plus r2. Clearly then that implies the 2 circles are touching one another externally. Implies that they have 2 direct common tangents and 1 transverse. Overall 3 common tangents, which is matching with the option 2 of that problem. In the last problem, it is related to the differential equation. After simplifying this equation, one thing you can clearly check that this differential equation is in linear form. Since that is in the linear form, you have to find out its integrating factor. That is nothing else but this, which is clearly equivalent to dt by t, where t is ln x. Hence this value turns out to be ln of ln x e raised to the power of that quantity, simplifying to only ln x. So solution would be, and then integral of 2 ln x dx, which is simplifying to this expression along with the constant of integration. Since it is given in the problem that x is greater than equal to 1, obviously you can check that at x equal to 1, what is the value of y? We should not be really bothered about. If we put x equal to 1, you will end up getting the value of c as 2, and once you know c as 2, just you need to put x equal to e in this expression. You have to find out the value of left hand side, which you can check is matching with itself, which is matching with the option 2 of that problem.